John here from bootcamp.com. Welcome to another video. In today's lesson, we're going to be taking a look at some of the descending motor pathways which we've been building towards. We're going to be looking at specifically the pyramidal tracts. And there are two types of pyramidal tracts. We have our corticospinal as well as our corticobulbar. Now the corticospinal, these are divided into anterior and lateral corticospinal tracts. And the corticobulbar, these have individual tracts for each cranial nerve nucleus, which we'll look at. So if you want to pause and take a look at the outline, you can do so, but let's just get started. Now, before we talk about the individual pathways, let's talk about the functions. So the lateral corticospinal tract, this is going to be involved in controlling the muscles that are responsible for precise and highly skilled movements, specifically in the hands and feet. So these are going to be found innervating those muscles in the forearm, which are controlling the hands, as well as those muscles in the leg, which are controlling the feet. Now, an example of when a highly skilled movement would be performed is if you were playing something like piano. This takes high precision in finger movements. You're moving a lot of different fingers at once, and the lateral corticospinal tract is going to be responsible for allowing you to make those movements so precise and highly skilled. So that's lateral corticospinal. Now the anterior corticospinal, this is involved in controlling the muscles of the neck, trunk, and proximal limb. Now these are going to be involved in more gross movements. Let's say I'm turning my trunk, twisting my trunk, or let's say I'm extending or flexing my knee. These are activating large muscle groups and performing more gross movements, not highly refined motor movements. Now, what you'll see is the corticospinal tract is actually going to descend, and it divides at a certain point known as the pyramid or the medullary pyramid. And at this point, 90% of those fibers are going to go into the lateral corticospinal tract, and only 10% are going to go into the anterior corticospinal tract. If you think about it, we need to have more motor neurons controlling more lower motor neurons to perform those highly precise movements in the fingers and feet, whereas you don't need as many upper motor neurons and lower motor neurons to perform gross general movements. So going back, let's take a look at the actual pathway for the lateral corticospinal tract. So starting off in the primary motor cortex, let's say we have an upper motor neuron, which is going to be controlling the hands. This is going to descend down through that corona radiata in the internal capsule. It's going to pass through the cerebral peduncles down, and then at this point of the medulla, this is where it's going to decussate at that medullary pyramid. So it's going to pass backwards and decussate, and it's going to continue to descend down our lateral corticospinal tract, which, if you remember, is going to be that tract or that area just lateral in that lateral column. So it's going to continue to descend, and then once it reaches that target spinal level, it's going to synapse with a lower motor neuron found in the ventral horn, and then that lower motor neuron, of course, is going to exit and go and stimulate that specific muscle. So next up, we have our anterior corticospinal tract, and this also begins in that primary motor cortex. It's going to descend down the corona radiata internal capsule, passes through those cerebral peduncles, continues, and then at the point of the medulla, it's not going to decussate. It's going to continue down in this anterior corticospinal tract right here. So it continues down, and then once it reaches its level, then it decussates and goes to the ventral horn, where it's going to synapse on that lower motor neuron, and then that lower motor neuron leaves through that ventral root and goes and innervates those muscles. So let's draw that out. So remember that anterior corticospinal tract is found on that anterior medial aspect, or the anterior white matter column. So this is the anterior corticospinal, and this is the lateral corticospinal. So you can see they both decussate. It just depends on the point of decussation. Lateral corticospinal decussates at the medulla and the medullary pyramids, and the anterior corticospinal tract will actually decussate at the level at the spinal level for which it's stimulating that lower motor neuron. So what would happen if we had a lower motor neuron or upper motor neuron lesion in one of these pathways? Well, if we have a lower motor neuron lesion, then we're going to see ipsilateral effects. And that is because, let's say we're destroying this neuron right here, because this lower motor neuron lesion is already on the side for which it's going to stimulate the muscle, you're going to see it on the same side, the ipsilateral side. However, when we take a look at the corticobulbar tract, you'll see that this is not always the case when we have a lower motor neuron lesion. Now, if we have a upper motor neuron lesion, we can see both ipsilateral or contralateral effects, and this really depends on the point of the lesion or the level of the lesion with respect to the point of decussation of each spinal pathway. So let's say we have a lesion up here. What are we going to see? Well, we're going to see contralateral effects because this neuron is going to come down and then it decussates or crosses over to the other side and it innervates the lower motor neuron on the contralateral side. Whereas if we had the same upper motor neuron lesion, but we had it somewhere right here, then you're going to see ipsilateral effects because it's already past that point of decussation. So we're going to see a loss of motor movement on that same side. When we're talking about the anterior corticospinal tract, it's kind of weird because the pathway stays ipsilaterally the entire time and then it crosses over. So the majority of effects that you'll see with regards to the anterior corticospinal pathway, these are going to be contralateral because we always have the point of decussation at the level of the spinal cord. So anywhere throughout the pathway, you're going to see that this is going to have a contralateral effect if we damage it up here. The only way we'd see an ipsilateral effect is if we damaged it somewhere down here near that point of decussation.